Good evening, friends. Welcome to Eason Academy. We are into embedded system programming, and we are discussing about the part microprocessor. And this is the session 4 of microprocessor. And the first session we discussed about introduction. The second session we discussed about assembly language and machine language. The last session we discussed about clock and resets. And this session we're going to discuss about the final critical part is memory map. Okay, so what is the memory map? That's a very tricky one. So let us try to discuss it. It's a very important one, and try to understand it in the very top level. So I told you once again, never go in depth. Always try to understand at the very top level first. If you're top level, if you don't understand, then go into the bottom level. Let us go from a very simple concept. You go to the class, your teacher asks you to buy a notebook. And she said that I want ruled pages for English. I want plain for science. Sorry, maths. I want a plain for math. And she wants in a single notebook like this. And for you, your father went and searched all the shops. Your father could not able to find a notebook which has first 100 pages. See, ruled, and second 100 pages plain. He couldn't find it. So your father is very intelligent. What he did, he bought two notebooks. One is ruled, one is plain. Understood? One is ruled, one is plain. So what he did was, he bought the two notebooks, and each notebook ruled is 100 page, 1 to 100. He found a plain notebook, which has 1 to 100 page. He put both of them and stitched together. For your teacher, it looks like a one notebook. Actually, it's a two notebook. Your father bought it and removed the cover and then stitched. So this became 1 to 100, 200. Am I right? Now this became a 200 page notebook, whereas first 100 pages, 1 to 100 are ruled, and 101 to 200 are all plain. Understand this? It's one of the simple concept. How do you stack multiple notebooks? Let us assume that. Let us put in a simpler another form to make it. I have 4 notebooks. One is green, one is red, one is blue, one is yellow. 4 colors, and each one is 100 pages. Individually, there are 1 to 100 pages. I combine all of them together. I put green first, red second, blue third, and yellow fourth. Now green is 1 to 100. Red is 101 to 200. Blue is 201 to 300. And yellow is 301 to 400. Am I right? This is called, I can call this a map of notebook. Do you understand this? If you understand this, is very nice. This is what all about we are going to discuss. I need one notebook. I try to combine everything on a single. Am I right? But each one is individually 1 to 100. But for example, I change the notebooks. I change the notebooks now. I now put blue to first notebook and green to last notebook and red to third notebook, yellow to second notebook. Now this is blue, this is yellow, and this is red, and this is blue. Sorry, this is green. Now blue becomes 1 to 100. That's it. So your map will change. How do you connect? Who connects is you. You are the one. Like that happened here. Here, what happened? There are the memory, there are majorly two types. There are two types of memories are there. There are two types of memory. Actually, there are 4 types. I'll tell you what are the 4 types of memory. First one is a block. I write here 8 bits. It will get out. This is called in. This is called out. This is the first type. So this IC will have 8 pins. Output have 8 pins. Understand? So whatever I give it here, it will go out. Okay. Now, there's the next IC is like this. I have 8 input pins and 8 output pins. So whatever comes here will come inside. 8 input pins and 8 output pins. This is the second type. Third type of memory is this, quite simple. Where what I do here is I have a read, but internally I already connect them. 5 volt here, 0 volt here, 0 volt here, 5 volt here. That means that I connect these pins. Understand one thing? I connect these pins of the IC, 8 pins to 5 volt. These 3 pins, I connect them to ground. And once again, these 2 pins, I connect them to 5 volt. So now what happened? I told you there is a 2 types. One is called whatever I give, it will go out. Other one is whatever it's coming, it will come inside. The third one is there is no input. Already what happened within the block, I given an input, fixed input. This is called fixed. You cannot change it. But I can only read. I can only read. I cannot write it because this is a fixed one. You understand? That's why they call this as a read only memory. Because I can only read. This is called ROM. I have a fixed everything inside. This one is called output. Whatever I give will go out. And next one is called input. Whatever is coming, it will get in. And fourth type is called, see, we have discussed now the word ruled notebook and unruled or plain or science notebook. Off ruled, 1 page is ruled, 1 page is plain. Science notebook. Maybe other one should be drawing notebook. So in a class, you are using all of them like that here. Each one is having its own purpose. So what is the fourth type is very important. Fourth type. Please understand. If you could be able to understand my explanation of the block level without going in details, you accept like that. That is what today's technology. This is indirectly, I'm trying to explain you that what is today's technology. You need to be able to read the document and try to understand, because a single IC is produced by thousands of engineers working together. And if you say that, unless I understand the IC, how it functions, I will not get into the IC, then you have a problem. Please understand, this is a very, after a long study of the industry, the students, I have come out with this concept where try to explain at the top level how things are working. How things are working. This is the fourth device where I give a input. The input goes there. Please hear like this, the output. But it does not come out. It is coming inside itself. Please understand. If I give a signal called write, I will write it here. If I give a signal called read, I will read it here. Understand? This, I will give a signal called read. Here I will give a signal called write. Here I give a signal called read. So, now understand one thing. I have data. I have a write means it will write here. When I read it, what they have done is they have connected this together internally. They have connected internally. So please try to understand there are only four. This is all together. Your entire computer, entire embedded system programming is only this. This we are going to discuss what is inside thoroughly in our digital electronics class. Okay, what is inside? But please try to understand the very top level picture of this. That is, there are four types of components we use in our computers. The first type is, that is, these components are connected to microprocessor. The first component is output. It gets in, gets out. Second component is input. And third component is read only. Fourth component is read write. Okay, these two are called memory because they are not outputting anything, they are not inputting anything, they only remember inside. So learn, see, please try to understand, learn this concept of accepting from top to bottom approach. If you need to practice this slowly in the coming days. These are the four are connected with your microprocessor. That's it. This is what all about system. This is what you connect your motor, LED, or whatever it is, Wi-Fi, whatever it is that. Input, you connect the switch, all these things. Read only memory. What is the difference between these two? The moment you power on, this is, since you give a permanent connection, everything internally. So this is going to be non-volatile. This, as long as power is there, whatever you write will be there. The moment you remove the power, this guy will go off. Understand? Each one is having their own property. There are four properties. Understand? This four is a one, actually two. Actually not four, actually only two. This two is a one. We are using it to build another two. This is called read only memory. This is called read write memory, or but we are calling it as a RAM. We are calling RAM, but actually it's read write memory. We are calling RAM. That's good. There's a small confusion there. That I'll explain to you in the memory case. Don't try to get in. Right now, you know that RAM. Keep it RAM. So there are 4. One is input, one is output, one is read-only memory, one is RAM. Now, what people thought, each one is going to store 1 byte. Okay. But in your college or school, you have a lot of students will be there. Lot of students will be there. Each one is having a name. Each one is having a name. So one K could be Bala, Ganesh, James, Balu, whatever it is. If you call Ganesh, this guy will say yes, because that is his name. If you say Bala, this guy will say yes. So like that here, what happened? We have so many units are there. You depends on the usage, you have the unit. Everybody, whether it could be a input, output, or ROM, or RAM. Now, from this guy gives address. Let us assume this guy is having a 10 wires. 10 wires means, let us take a very simple 4 wires. 2 power 4 is 16. That means 0002, 0012 up to 11111. Now, if I say, let's say this guy name is 000. This guy name is 001. This guy name is 1010. 101. Because 4-bit, all the people. So this guy name is 1110. Like we have a name called Ganesh. Here the name is like this. What happened? There is a small block here. There's a small block. This block takes this input from everybody, from the microprocessor address. This block takes, it gives you one signal called select. Understand? This guy is called select logic. Select. Please understand the top level, how many blocks are there. You have a block called microprocessor. You have a block called this floor. And each one is, this guy name, it could be, this guy name could be 000, 001, 1001, 110. These people don't have a name actually. Because you connected here, they get the name. Because you connect this guy here, they get the name. This is called select. So this is a very top level picture of the entire computer architecture I've drawn now. You'll be very surprised how we are going to connect that, how this is going to be used for your embedded system programming. That's a trick. Okay. Once you're done with C programming, I'll explain to you that how to do it. Now, in your class, you will be having so many people, 100 people in your class. Some 10 people are interested in football. They will make a team called football team. Understand? There'll be a team called football team. In the football team, all the players like football. They have a unique characteristics of football. There may be one more team called cricket. That there are so many people with cricket status. Understood? Like that, you make a team. Here, people, instead of using one, they make ICs. They make ICs with multiple ROM units. Each unit store only 8-bit. Each unit store only 8-bit. Now there is 1 byte. Now I have 4 of them. That means that you can call this as a 4-byte ROM. You can use any amount of You can collect any amount. Let us assume that I'm using 1024 byte units. That means that they have a 1024 byte ROM. That's actually a call team. This is a one team, like a hockey team. Now I have a ROM team. The ROM team is having 1024 bytes units. Since 1024 units, each one is having a select logic. And for 1024, 2 power 10. So they get 10 address lines. So this guy name will be, since 10, the starting name will be 000 up to 11111111. Please understand this. So the only problem is this. When I have told about the notebook, when I told the notebook, I have a 4-colored notebook. Green, red, blue, or a yellow. 1 to 100, 1 to 100, 1 to 100, 1 to 100. When I combine all of them, it becomes 1 to 100. It becomes 101 to 200. 201 to 300. 301 to 400. You understood easily because you daily deal with the notebook. You don't have any doubt here. Here also same thing. What happened? I have a notebook or a ROM memory or ROM IC, which has 1024. I can have any number. Now, how do you address? That's why I tell very simple. First, we assume that I have a 4. I have a 4 ROM. I'll explain to you why you need non-volatile, why the volatile problem. Now I need to have a 2 address lines. The 2 address line means 00, 01, 10, 11. Please understand. You understand? 00 means first one. So this guy name is 00. This guy name is 01. This guy name is 10. You connect. Okay. You can have any number internally. For example, in your pen drive, okay, in your pen drive, you have 32G pen drive or 32 micro SD card. How much 32G? That means that I have internally that much and I have address lines to collect them. That's a trick. Okay. So the number of address wire decide that what is the capacity. Now let us assume that I have a ROM which is 1024. I have a RAM which is 1024. RAM is a volatile. ROM is a non-volatile. You understand? RAM is a volatile. ROM is a non-volatile. What is non-volatile? Even if you remove the power, inside is permanently there. As I told you that it has internally all wired to 5 volt and 0 volt. It will never change. But the RAM or read RWM, you will change it. That's the problem here. But both of them have a no output. You can only write and you can only read. In this case, you can only read because ROM is only read. The RAM you can write and read by only microprocessor. That does not get out. If you want to control something, I need to have an output. If you want to monitor something, I need input. This is what connected to the microprocessor. So this whole thing is your system. And as I told you, this is a clock. And you have a reset. And you have a power. And you have this. Now, how do you connect them is a trick. Because from here, I have only one address line coming out. How do I connect them? Now let us take how do I connect? If you understand how do we connect, then fairly we have a good idea. Now let us assume that I have 6 wires. So the microprocessor can address from 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 1, 0, like that up to 1, 1, 1, 1. This whole thing is starting from 0 to 63, because 2 power 6 is 64. Am I right? Now I have block here. Each block, I have 2 blocks. 2 blocks. Assuming that I have 2 blocks. One block is 32. Another block is 32. One block is 32. Another block is 32. That means that each block is having 32 units, small units. This guy is having internally 32 units, small units. So how do I connect them? So this guy is having 32 bytes. So he has 5 address lines. He has 5. 2 power 5 is 32. So he has so many select blocks. So many select blocks. The select block is 0, 0, 0, 0. This block number is 0, 0, 0, 1. This last block is 1, 1, 1, 1. See, in our case, if I have a 4-digit number, we start from 0, 0 to 9999. Like that here, 0, 0 to 1, 1, 1, 1. 1, 1, 1, 1, 0, 0 means 0. 1, 1, 1 is 31. Because 1, 2, 4, 8, 16. 16 plus 8, 24. 24 plus 4, 28, 30, 31. Now, this day also having same thing, 0 to 31. And they have internally a block, 0, 0, 0, 1, 1, 1, 1, 1. Okay, now this guy also have 5 wires. So now think of it. I have, now understand here, from this guy is giving 6 wires. Here I have 5 wires, I have 5 wires. How do I connect it? Now this is all A. What we do here is trick is here. This is nothing but 6 wires. We call them as a A0, A1, A2, A3, A4, A5. Because 6, we put /6, 0 to 5. Now this guy is having 5 wires. A0, A1, A2, A3, A4. This guy is having 5 wires because they are only 32. I told you already that 2 notebooks, 1 to 100, 1 to 100. I combine together to get a 1 notebook of 1 to 200. Now I have 0 to 31, 0 to 31. I combine together. How the microprocessor will see now, it's as a 0 to 63. Understand? How? Now let us see now. Now these 5 are connected. Now these 5 are connected. These 5 are connected once again to this guy. Understand? They are connected wires. So if we give here address 0, 0, 0, 0, 0, 0. Since A5 is not connected, now these are connected. So 0 to 0, it goes here. It goes to this guys as well as this guy. So what happened now? Because of that, the first one is selected in both the places. And both are going to give out data. But which you don't want. You don't want this guy to this guy. How do I select? This 0 is the top one because this is 0 to 31. And this one is going to be 32 to 63. How do I select? What we did was very simple. We used this 0 block. We use this 0. We have another block. We have 2 blocks. This block will select the chip select. This is a chip. They call it a chip select block. Now, let us assume this guy name is 1. This guy name is 0. There are two names. I can have a name of only 1 bit. Now 0 is coming now. 0, 0 matches. So this becomes 1. So this is selected. And this guy is giving 0. This name is 1. 0, 1 does not match. This becomes 0. So if your name is not Balaji, you will not say yes. Same way here. The blocks are having a name. The moment I don't have a name, that guy is going to keep quiet. So the end of the session, I'll give you some very important tip that then you will understand the whole logic. Maybe I know that the top level pictures you don't understand is because you have been always dealt with understanding from the bottom level. But the world is changing. You better have to understand the block levels. Everything is going to be people write block. You need to understand now onwards, start practicing. That's why I'm starting with the block. Then I'll go down how to do it in what is inside the block. So, like you call somebody with a name, that guy will say yes. Like that here. These guys are names are now only 1 bit, 0 and 1. Why not have a 1 bit name? Like we have a only Ram. Another one is Ananta Gopalakrishnan. You can have it now. Like that here, I can have a name of small. Am I right? Now, see here, if the microprocessor gives address 0002, the microprocessor gives the address. Let me write it here. Let me write it here because I will have a space. If a microprocessor gives address 0002 0111, that is 0 to 31. What happens? This A5 is 0. And this is connected here. So this becomes 1. This is selected. So 0 to 31 means ROM. Now, you see here, when I store from 1002 11111, this become 1. Because these two are 1. This is what is coming out is 1. And this is 0, does not match. So this becomes 0. And this is 1. 1 is matching, this becomes 1. So this one is selected. This one is not selected. So from 32 to 63, what is selected? RAM is selected. Now I have 2 notebooks. One notebook is ROM, other notebook is RAM. 0 to 31 and 0 to 31. Understand? When I connect them, okay, I can give a name. This is the way they connect. Suppose I know that I'll confuse you a little bit. Then I will say that how to avoid the confusion. I will confuse you a little bit because we are going in depth. Whenever we go in depth to confusion, let us say I have 4 notebooks. I have 4 notebooks or 4 chips. One is called ROM. One is called RAM. One is called output. One is called input. Example. All of them are having 16 bytes now. 16 bytes. 0 to 15. 0 to 15. 0 to 15. 0 to 15. That means 16 bytes. 2 power 4 is 16. So they have 4 address lines. Now what I'm getting is, I'm getting now A0, A1, A2, A3, A4, A5. I combine these 4, A0 to A3, and connect it to all the people. Now all are selected. Each one is having a 16 unit internally. Each one is having a 16 unit internally. All are connected. Now I have 4 boxes now. I have 4 boxes because I have 4 chips. This box name is 00, 01, 10, 11. Now this A4 and A5 are going to both all the people. Now think of it. Now let us take a this one. This is connected to here. This is connected here. The trick is that when I'm completing, please, you may be confusing now, I know that. But we wait for about another 5-10 minutes. I'll try to remove your confusion. Okay. There you go. There you have 2 options. Either go through this method or wait for digital electronics class, then attend the microprocessor. That's fine. But this approach, if you trying to understand this approach, we're done. Now the microprocessor can give 00, 00, 00, 00, 1111. This is 0 to 15. Now the 2 lines A4 and A5 are 0, 0. Because that is 0, this is selected. So this ROM is selected. Then when you have 0, 1, 0, 0, 0, 1, 1, 1, 1, that is 16 to 31. This is 0, 1. That time this is not selected. This is selected. Now this is selected. And then 1, 0, 0, 0, 0 to 1, 1, 1, 1. Now what happened? This is 1, 0. That is 32 to 47. Which is selected? This is selected. Now last one is 1, 1, 0, 0, 1, 1, 1, 1, 1, 1. Both are 1, 1. Now 48 to 63. Which is selected? This is selected. This is because 1, 1. All are zeros. I know that your problem is you are not very familiar with binary. Okay. That's why I've given a number system video. Watch it. Or go back and watch the video 2-3 times. You will thoroughly understand. But if you understand what I've explained now, this is what your PC architecture, this is what your computer architecture. But the trick here is we change the connections differently. We change the connection differently because sometime I may be having a chip with 32. I may be having a chip with 16. I may be having a chip with 8. I may be having another one with 4. Understand? Not all need not be same. In this case, how do I do that? I get 6 here. I connect 5 here. I use the only one more here and connect the select. In this case, 16, 4 wires. From here, I have taken 1 here, 5 here. From here, I have connected 4 here and 2 here. From here, I have connected 2 power 3 is 8. I take 3 here, 3 here. And when I get here, 2 power 2 is 2. I connect 2 here. I take the 4 here and connect. This will confuse you. I know that. Now I do the other way. You totally forget this. You totally forget this. Now you come to the college level. Then you understand. I have a team. I have 4 teams. I have 4 teams. Each team is having 1 to 10 people. Each team is having 1 to 10 people. This is a hockey team, cricket team, football team, basketball team. Understood? Each one is having 10 players, assuming only 10 players. Inside the team, they have 1 to 10. Inside the team, they have a 1 to 10. Everybody is saving 1 to 10. Inside 1 to 10, 1 to 10, 1 to 10, 1 to 10 inside. Now, from the whole school point of view, hockey team is the first team. I give an ID called ID 0. I give an ID here 1, ID 2, ID 3. We call ID. Now this is 0 and you have 10 people. So this hockey team start with 0, 1 to 0, 9. So 10. Let us make this as a for our simplicity. We make it as a 0 to 9, 0 to 9, 0 to 9, and 0 to 9. It will be easy for us. So hockey team will have a 0, 0 to 0, 9. This is ID. This is player. Then 1, 0 to 1, 9, because the ID is 1 here. And 2, 0 to 2, 9. That is a football. 3, 0 to 3, 9. This is called your map. Suppose I have only the basketball team. I have only 4 people. 0 to 3. Then I'll have 32, 33. Am I right? So I just explained to you that how we connect them. Like that. Here, what we do here is, if this microprocessor is giving the address, we have so many components. We have so many components. N number, not 1 or 2. You may be having 100 components. The beauty is, this guy's address, if you have a 6, 2 power 6 is 64. You have 4 people. This guy is having 32. This team, 16, 8 and 4. Add together, 32 plus 16 is 48. 48 plus 8, 56, 60. Oh, good. It is possible. Suppose, if you have these teams, it's not possible. Because I can address only up to 64. This is already exceeding, and it's not possible. So you cannot do like that. Now, what is the starting address of each one? This guy's starting address is 0. So he already captured 32. Okay. So this guy is starting from 32 because we start from 0, 31. This guy is 16. So how much? 48. 48 plus 8 is 56. That's it. Now, this is what the trick. What we do here is, every component in the circuit, one is ROM, one is RAM, one is input, whatever it is. These components have their own work. This ROM is non-volatile. RAM is volatile. So I have mentioned to you that when I write a program in C, when I write a program in C, int A, B, C, A equal to 10, B equal to 20, C is equal to A plus B. If I compile that, I'll get assembly, then I get machine code. The machine code will be numbers, whatever it is, some numbers. This is called your machine language. Normally what we do is, we put this inside the ROM, non-volatile. Because when you power on the microprocessor, once you give the 5 volt to the microprocessor, it always tries to read from the ROM. ROM will have a non-volatile, the data will be permanently there. But I say ABC, these are all called variables, which I have to write, because you are writing. In ROM, you cannot write, it's only read-only memory, but it's a non-volatile, read-only memory. So what we do here is, whatever we execute the instruction will be there in the ROM. ROM will have an instruction. That is your program. Your program will be there in the ROM. But RAM, we use it for variables, or we call data. where I have the ability to read and write. RAM is having a read and write. So all variables are stored in the RAM and all things are stored. Now, let me take a very slightly bigger picture. Let me give you a bigger picture now. Now, I have a microprocessor which has 16 address lines. That means the 2 power 16 is 65,536 or 64K. Now, I have a ROM of 8K. So I start from 0 to 8K minus 1 always because it's, that starting is minus 1. In decimal term, 81950. But we'll do like this. Now, I have a RAM. The RAM is having another 8K. So I start from 8K to 16K. Understand? Now I have one more chip. This is device 1, device 2. So I chip 1, chip 2, and chip 3. Chip 3 is having 4K. It starts from 16K to 20K. Same what you do on notebook. This one is a thing called memory map. Your total memory, that is, say in my microprocessor, this guy address 16-bit. So total memory is 64K. Out of which, how much is ROM? How much is RAM? How much is this one? What do you call it? Output. How much is input? This each one starting address. And this is, you have to have this information. How this information is going to be useful for us. That is the one we'll discuss on the Tuesday class, coming class. But if you could able to, I know that it's sometimes it goes beyond your head, but I try to avoid all the big terminologies. Okay, I try to explain everything in a block level. So please try to understand these blocks. Everything is block. Now, the thing is that two important functions are there in microprocessor: store or any register to address. Load any register to any address to register. This can be anything. For example, you have a 64K 0002 FFF. That means that this 0 represents 000. And this represents. Understand? This is a trick. If you understand this is 0, this is FFF, 65,535. That is FFF. I can write anything here. That means that using these two instructions, the microprocessor talk to the external world. So what happens now? Tell me. I'll tell you a bigger picture now. You have a microprocessor. I have so many components. Each component is having a small elements based on the property. If it is ROM, all this will be ROM. If this is RAM, all the single units are RAM. If this is output, all the single units are output. Now, each one is having a select logic. So that is based on the size. You will have address. If it is 1024, that means that 0 to 1023. You will have 10 wires. So you will have 1023 select logic, 1024. This guy name is 0, this guy name is 1023. And this guy, let's say you have a 512. Then 0 to 511. This guy name is 0, 511. You have only 9 address lines. And this guy may be having, let's say, 16. Then only you have 4, 0 to 3. This guy name is 0, this guy name is 3. You have only 2 lines. Now, microprocessor is giving 16 wires. This guy have a 10. I connect the 10 here, and remaining 6 is connected to the logic and select the chip. So this is used to select the team. This is used to select the individual inside the team. Now this one, I get once again 16. I divide 9 here. I divide 7 here. And I get the 16 here. I get the 2 here. I get a 14 here. So what I'm trying to effectively say is quite simple. Each component is having a unique starting address and unique ending address. No 2 components will have a clash. Like when you have 4 notebooks, red, green, blue, and yellow. This guy is having 1 to 100, 101 to 200, 201 to 300, 301 to 400. It does not clash. Like that here, so many components are there without any clash. Now the trick is, how are we going to access the components? Understand? It's a simple C program. That before that, I told you that 2 instructions, load and store, 2 assembly language instructions. And how are we going to access them from C program? That we will see in the next class. So that time you will fairly understand, and whatever I discuss here, you can coolly forget today what I discussed in the second session. Remember only one thing. That means that I have so many blocks. Each block is having own size. And each block is having a starting address. That's it. If I give the address, if this guy is having 1000 and this size is having 200, that means that 1000 to 199 is here. So if a microprocessor gives address 1020, that belong to this guy. That's it. If you understand that, I would have confused you a lot. That's why I told you, even though I confused, at the end, I will remove the confusion. You can coolly forget what I discussed in between. I want to tell you that how these things are available there in the chip. But what you have to remember is this. I have so many components. Each component is having a starting address. Okay, or we call this as a base address. Starting or base, both are same. Base address. And this is called offset. So if you want to access this guy's starting address is, base address is 5000. And you want to access the 50th register. You have to add 50th location. You have to add base address plus offset plus 50. You get 5050. Every component is having a unique base address. That is what shown in your all the designs. I will show you a data sheet by Monday. Then you will know thoroughly this. I wanted you to have a look at them this weekend. Okay, on Tuesday, next class, I will show you a data sheet. How these things are exactly shown. What I explained in the class is exactly there on your data sheet. Then you will believe, oh, I explained to you the same thing. What is that in there? I might have confused. I know that. I'm very clear. I might have a little bit confused you, but don't worry about that. That if you could not understand, it's very good. If you don't understand, that's not worry. So by giving the address, load, and store, I can address any of these things. But how do I do it in C? That we will discuss on the next class. Okay. So this is what a memory map that is called. In a memory, I have so many components, and sometimes I may be unused also. Unused or reserved for other purposes. And this component, that is called device 1. 02 002 something. Let us assume that in a hexadecimal 0002 1FF. That's called 8K. Then this one is called 2002 2FFF 4K. This is all reserved. This K is from 8002 CFF BFF. This is 32K. How I have written this? That watch my numeric number system videos. You will understand this. If you don't understand hexadecimal, let me know. I'll be able to give you another video for that, only for the hexadecimal. Try to understand how I've written this so quick. 32K. So not 32K, 16K. Okay. So this is called memory map. That is, each component in your computer, in your embedded system, in your microprocessor design is having it. Yeah, this is the most confused topic, but most important. If you understand this, you understand microcontroller. If you understand microcontroller, you understand embedded system. That's it. That's a trick. That's why I always request people to watch the videos few times. Every class I explain differently. So you'll be able to, I'll give you other videos also, the other classes. You'll be able to understand it differently. This is not the same thing what I discussed in the, I'm not a machine, I'm a human being. I've not explained the same thing in the first two classes. If you want to have a different view, you can take the other previous batch classes. It's available. So every component in the system, which is accessible microprocessor, is having their own base address only. So they're all not there's no intersection or anything, no confusion. Each one is having their own block. Each one is having their own range. That range is called memory map. You have to know that. I know that you were a little bit confused, but I'll clear that on Tuesday. That also. But by the time you have to do a help. Please watch this video a few times. You will get to know that. Otherwise, I will not tell you that this after C programming. I told you first one is C programming. Second one is memory map. It's a very little topic, but you should be 100% thorough with it. You should be very thorough about memory map. Understand? That's a very important one.